Okay, question number 6 deals with the same information. Give me just a moment and I'll bring up the text version here and I'll read it aloud. Okay, so the text says, the scientist creates an equation that models her data for each tree so that she can predict the diameter in the future. Complete a linear equation that fits the data for tree 1, where x is the year and y is the trunk diameter in inches. Click on the variable and number you want to select and drag them into the boxes. They do have multiple choice answers. I'm not going to list those now because it's not necessary. If we don't know how to arrive at those numbers, we're really doing just a guessing game anyway. So I'm going to pause just for a moment. Okay, so what they're looking for us to do in this situation is they set this up as y equals mx plus b. What that means is m is going to be the slope. So that's the first thing we're going to do here. We're going to find the slope of these 2 points. And then we're going to talk a little bit about the last piece, the y-intercept, where the line crosses or intersects the x-axis. Okay, so x is going to be here. That's a gimme. I don't know if they give you credit for that or not. I'm not really sure, but it was one of the multiple choice answers. So I guess if you can recognize that the x goes there automatically, you may get an extra point. So we need to find the slope here, and we need to find the y-intercept here. And we are given 2 points. What I did when I rewrote this graph is I just included year 1 and year 3 because that's all we need. We just need 2 points. This will be our first point. This will be our second point. So what we're going to do is we're going to find the slope. You do not need to memorize this. This equation is given to you on the formula sheet. And it states m, or slope, equals y2 minus y1 over x2 minus x1. So this is the formula that we're going to use. We need to know which numbers to use. What I like to do in this situation is I'm going to take this first number and label it my x, and I'm going to label that guy my y. I'm going to label this my x and this my y. Let's do that right away. Since this is my first set of numbers, I'm going to label that x1, that's y1, and this I'm going to put a little 2, I'm going to put a number 2. So again, what I did is I labeled this xy, I labeled the next set of points xy, and then I came in and I put a 1 and a 1, I came in and I put a 2 and a 2. Once we do that, we know what number belongs in what position. So let's look at this formula and follow it. It says y2 minus y1. So y2, as you can see, is 19.2. So we've got 19.2 minus y1. We marked that next to the 18.6. And then down below we've got x2, which is 3 minus x1. The x1 in this case is 1. So doing the math, we punch this into our calculator, we get 0.6 on top. 3 minus 1 we know is equal to 2. So we punch this into our calculator. 0.6 divided by 2 gives us 0.3. So at this point in time, we know the slope is 0.3, and we can mark that in the first box, 0.3. Now we need to determine the y-intercept. There's a few different ways to do this. At this point in time, I'm going to skip the normal textbook approach where they give you a formula to follow when you're given a point and you're given the slope. And I want to look at this a couple different ways right now. We'll come back to the textbook method. Here's one alternate method to find the y-intercept in this situation. So this first point, if we had to graph it or plot it, we know we'd be at year 1 and would go up to 18.6. That would put us right about there. We go to year 3, we go straight up until we hit 19.2, so that would put us right about there. here. Let's take a look at this. We know that from this point to the next point, it rose a little bit. We can see that. Plus, the slope is telling us that's going to rise a little bit. It's going to go at an upward angle. Now, one of the things we can do here is we can figure out how much this rose by. So from year 1 to year 3, we can see it went from 18.6 to 19.2. So if we do a little subtraction on that, we know that it increased by 0.6, which is the slope, divided by 2. So at this point in time, if we want to know what the increase was from this point to this point, well, since this is 1 year and this is 2 years, that must mean that if this is a linear equation, and it is, that must mean that if 2 years covers 0.6, 1 year must cover 0.3. So that must mean that if we're at 18.6, and we are, and we subtract 0.3, that would put us at 18.3. I may have to edit all of this. We're going to continue because this is absolutely correct. I did it incorrectly the first time I worked it out. So as you can see, that means that each year it's increasing by 0.3. So if we back up 1 year, instead of being at 18.6, it would be at 18.3. That means the y-intercept has to be 18.3. That's one way to do this. We're going to mark that down, and we're going to look at another alternative method. So at this point in time, we're done. Let's just take a look at another view on this. At this point in time, we're just going to check our final answer. We're saying that this is the final equation. Y equals 0.3x plus 18.3. If that is the correct equation, that means we can take any of these points, plug them into the equation, and it should work out. We should get a match. So let's do that with the first point here. We've got 1, and we've got 18.6. So I'm going to put my 18.6 in place of y. I'm going to put a 1 in place of the x. So I get 0.3 times 1 plus 18.3. Let's work this out to see if we get a match, because we should be able to get a match if it's correct. We get 18.6 equals 0.3 plus 18.3. As you can see, 0.3 plus 18.3 does indeed give us 18.6. We do get a match. That tells us we have the correct equation, and we were able to check that by inserting that first point and working it out. Again, that's just one alternative method to find the y-intercept at this point.